So, welcome everyone. Thanks for coming. My name is Måhlén, and I'm from Spotify, and I'm going to talk to you about Mobius, which is a functional reactive framework for managing state. Before I start, I'd like to check how many were watching the MBI talk that just happened over there? Yeah? Cool. How many were considering going to this talk by Munir Budra about state management of state machines? Some of you as well? Cool, because all these three things are very similar topics, and I think I'm not an MBI expert, but I would say that Mobius is really a flavor of MBI, and I think all of the things that they were talking about as advantages of MBI also apply to Mobius. We're doing something differently, and I have one slide that tries to compare Mobius with MBI because there was talk about this at this conference, and I think it's interesting. So the things we're going to cover today. First, a little bit about Android at Spotify to set the stage, like why did we design this framework and what are the problems we want to solve, so the objectives. Some information about the inspiration we had, like what else did we look at? We didn't invent this out of the blue. And then the meat of the presentation is this walkthrough of Mobius with code and stuff and all that. And then summing up with some of the things we've learned. So at Spotify, we have more than 100 monthly active committers in the main repo for Android. We have teams working in 6 different cities, more than 50 of them with Android developers. And we have more than 400 Android modules in our big mono repo. So if you're interested in some of the things that happen to give us those and what that's like, then tomorrow afternoon there's a talk by Elin Nilsson, my colleague, about modularization. How hard can it be? Harder than you might think, perhaps. A thing to note here, I think, is that 5 years ago, there were about 10 committers to the Android repo. So there's been a lot of growth very quickly. And that's behind some of the, that's partly the rationale why we want to come with this framework. If you look at what we did and mostly do still, there's a recommendation to use Model View Presenter for all of the different features in the app. And we're using RxJava for asynchronous stuff. So these are both really good tools, and there's nothing wrong with them. The thing that has happened, though, is that we didn't really have like a very strong statement about what a presenter is and how do you build it. So when you have that kind of explosive growth that we had in number of developers, that means that you get a lot of different interpretations of how to do things. So presenters in different parts of the app look very different. And at least for me, I don't know about you, but when you do complicated things in RxJava, then it gets really complicated, at least for me. Like, I don't understand large Rx chains where some things happen on subscribe, some on observe, and when you zip things together. Then. So when you use RxJava too much and perhaps manage state with it, I think it gets really hard. So, clicker. It's dead. So we built Mobius to try to address some of these problems. And we wanted to have a framework, not just a pattern, so it wasn't really open to interpretation. It would be used more consistently by all the different teams. We wanted something that was reactive in nature. So to make it easy to work with in a concurrent setting where, as you know, like you never know when the response from the backend server is going to come back, and you don't know when the user is going to click something and all that. We wanted to enforce a very strong separation of concerns. So, I mean, specifically, I would say between the user interface part and the business logic, because the business logic should be testable, and we wanted to be able to move very quickly through having well-tested code. And we also wanted to, like one way to achieve the separation of concern that we knew we wanted to utilize was to have a unidirectional framework, a unidirectional architecture. And side effects, so that's like things that change the state of the application. They are what makes it hard to understand an application, I would say. Because whenever something changes, you have to know what was it before and what was it afterwards. And you can't see that except by attaching a debugger or something like that. So that's like danger zones. And we wanted to separate them out so that they are, there's a red flag, and this is where you need to be very careful. And in general, we hope that this would let us get to simpler code. Does it work now? No. So some of the inspiration. Functional programming has been for a number of years now on the rise, and it's a trend. And there are some really useful concepts in functional programming that you can use, even if you're in an imperative language like Java or Kotlin. And a couple of the things we wanted to include was separating data from behavior. So in object orientation, you want to have an object that has data and behavior, and you encapsulate that, and that's a thing. But in functional programming, it's like the data is here and the behavior is there, and then you sort of can compose behaviors onto each other through functions. And the data, generally speaking, is immutable, doesn't change, it's value objects, it's easy, there's nothing difficult to reason about there. Immutability also, as everyone knows, I think has a lot of important benefits when you do concurrent programming, but I think the main reason is that it's easier to reason about stuff that's immutable. There's also the notion of pure functions. It's kind of an informal concept. I think it's actually called something much more complicated. But basically a pure function, if you don't know, is something whose output is only dependent on its inputs. So only the method parameters determine what the output is going to be like. There's no reading anything from disks. There's no using the current time or no random generation or anything like that. For a certain set of inputs, the output is always going to be the same. And the other criterion is that there can be no way of seeing from the outside of the function whether it was run or not. So like it cannot have any side effects. It cannot write to disk. It cannot change any state of anything. It cannot count the number of invocations or something like that. And those are, the cool thing about those is that they're super easy to test. And you can, in fact, forget about them, that they run. You can just inline them if you want, and so on. So they become very, very easy to reason about. And an example is addition here. So like it's a pure function. It's always going to return the same result, no matter for the same inputs, no matter what happens, and you don't know if it ran or not. And the contrast is obviously impure functions where you have like some specific side effect, or you don't know what the response is going to be. Okay. Looking a little bit at prior art, there's when we started this work. These are some of the things, it's not a complete list, that inspired us. So there was a talk by Jake Wharton called Managing State with RxJava. Redux is a framework, popular framework on the web, which does similar things to what we're trying to do. Cycle.js and MVI are also really similar. Maybe even more similar is Elm, which is a functional language for building stuff on the web. And they have something called the Elm architecture, which is extremely similar to what we do in Mobius. There's one difference in how we do what we call effects. They call commands. And there's a guy called Andy Matuszak who has published a gist on GitHub, which is brilliant. It's an implementation in Swift of state machines, and except for finite state machines, and except for the fact of mandating that the business logic be a finite state machine, it's exactly identical to what we have in Mobius, I would say. Cool. Okay, so enough introduction. Let's go through what it actually is. Did I say enough introduction? There's more introduction, actually. I lied. Sorry. So all programs can be modeled as a finite state machine. And so you can think of like evolution in the program as changing from one state to another, and then you have all these arrows that are transitions that are possible, and which transition you take from one state to another is triggered by some kind of event. And that's really how we do things. You can see it like this. So you have, in a UI context, you can have the program, which is a state machine, and then you have a user interface that observes the state, and the user interface is a source of the events that trigger new state changes and so on. This is the same in principle as in MVI and other paradigms. So, state. In Mobius, we call the state the model. So the model is different from in model view controller, where it's state and logic. This is just a data class in Mobius, and it represents the internal state of the program. And the example I'm going to use now is a simple login screen. And so, like it's clear when you do a login screen, you have two input fields for email and password, and you'll have a button as well that you can push. So in the state, let's keep track of the current values of the email and password input fields using an immutable data object. I should note here the slides are in Kotlin because Kotlin is the thing. In fact, at Spotify, we don't yet use Kotlin. We're still using Java. And if you're using Java, then you can use auto-value to the same effect. That's what we tend to do for our models. Then the events. So these are things that happen in the feature that can change the state, can affect the things that happen in the program. And if we have the view with the two input fields, then two of the events that can happen are that the input for email changed or the password input changed. So what we do then is we have some code in the UI that detects this, and a listener, and then we get the text value, and you send an event which is email input changed and password input changed. Events are, just like the model, they're immutable data objects. And for events, it's much easier they're much easier to work with if you use algebraic data types, sum types, so sealed classes in Kotlin. And if you're not using Kotlin, then we've created an annotation processor called DAY1 that gives you the same sort of thing as in Kotlin, but in Java. So just an aside. But yeah. So if this is kind of the way we want it to look, the way it is in Mobius is this. We have the user interface that generates events that gets sent to an update function, which is the heart of a Mobius application. The update function has the signature at the top there. So it takes in the current model and the event that just happened, and it returns the new model. And then the user interface observes changes in the model and updates itself based on that. And the model circles back so that it's available for the next event. Event processing is done sequentially and atomically, so there's like only one event that happens at a time, and when the next event comes in, if two come at the same time, then one's going to be selected and the other one will have to wait until the first one was processed. So let's write an update function for our login field. So we have a function that takes a model and an event and returns a model. With sealed classes, you can use this nice when expression. So we switch on the event. If the event is email input changed, then we record that fact in our model. So we return the same model as before, but update the email field. If it's a password input changed, we do the same thing, but not quite. And I'm going to move these out into methods because we're going to be doing more with those later on. OK, so now we have something that can just remember changes that happen in these two input fields. But we also want to enable the login button at some point, right? So so let's say that we have a field in the model called can login. So at some point, we can log in. And that's determined by this function that verifies the credentials. So, the password, the email looks like it's a valid email address, and the password has, the right number of characters or whatever. Details are not very interesting. So let's go back to our on email changed handler and update it so that it's recording the fact of whether the login button should be enabled or not. So if the credentials are valid after this change, record that fact. And similarly for the password button. OK. But now the button starts out disabled, and now it's enabled. And what happens when the user clicks the button? We need to have another kind of event. So what will happen is that there's an email changed and a password changed, and then the can login button will be enabled. It shows up in the model, it's enabled, and then you click. And that's a login requested event. It doesn't have any data in it because we already have the information we need in the model. We have the email and the password that we're going to use for logging in. And when the login is in progress, let's say that we want to show a spanner. So we're currently in the process of logging in. So we need to add some more data to the model, a Boolean that keeps track of whether login is in progress or not. And then we need to modify our update function so that we can handle this login requested thing. And here's an implementation of that. So if we are not logging in at the moment, and we can log in, then we say, OK, we're now logging in. But if we're already logging in or we cannot log in, then we're just going to discard that event. It shouldn't actually be possible for it to happen. But if it does, like because of a race or some unforeseen condition, we should handle it anyway. So in this case, we're just going to ignore it. But like now we're just saying that we're logging in, but we're not actually doing anything. So how do we do that? That's the next key concept in Mobius, which we call effects. And if you look at the heading there, you see that I lied again. Like the update function doesn't have the signature of taking in a model and an event and returning a new model. It actually returns a new model and a set of effects. So effects are things that the program wants to have to change in the outside world. And they're really similar to events. And I think if you went to the MVI transaction just now, the MVI talk just now, you saw that they were talking about how Redux works with actions, and there's a function that handles side effects that goes from action to action. So in Redux, events and effects are the same things, and they're called actions. We're separating them. But so events are inputs to the function, and effects are outputs from the function, from the update function. In this particular case, the two effects that we can see that we want to use right now are attempt login, or let's add another one, which is show error message. So attempt login means we need to pass on the credentials, and in the show error message case, we have a payload, which is the message to display. And the way that we return two things is through this type that we call next. So it's the, what should happen next after this event happened. And there are 4 factor methods for the next type. One of them is next update the model. The next one is next update the model and send these effects. Sorry. Another one is there's not going to be any changes to the model, but I want to send these effects. And finally, no change. This event happened in a state where it's not relevant. I'm just going to discard it. So let's get correct about the update function and change it so that it returns next. So in this case, we're using the first factory method, just saying update the model. And same thing for when the password changes. And now we can get to this onLogin requested method. And this is a direct translation. But we see instead of returning the same model, which means that the UI will render itself once more, we can just say no change, so there's no change. And then we can add, using this utility method called effects, which creates a set of effects, we can add the attempt login request. So now we're going to start that. And we can also say, if it happens that you are able to somehow click on the login button without actually being able to log in, then we can say, sorry, you can't do that. OK. So where do these effects go? What's the orange thing? Something needs to handle them. And we call them effect handlers, because why not? And these are impure functions. So this is where you change state, and this is where you do things that are dangerous somehow. And the way they work is that they're taking an effect, and then they can produce 0 or more events. So events from effect handlers are feedback about what happened. So for instance, if you think of some effect that starts the download of a file, you might have an effect handler that emits progress events based on the amount of stuff that's been downloaded, or something like that. And typically, effect handlers will be doing stuff like backend requests or writing to something to disk, or like there might be a timer or something like that. Anything that's impure, you typically do it through an effect handler. So getting back to the diagram, it looks like this. You have effect handlers, and they also generate events that will be passed into the update function. So, based on an attempt login effect, there are at least 2 outcomes. Let's think of 2 outcomes. So either you succeeded, and that's just it, or you failed, and then there's some kind of error message. And if the login is successful, let's say we want to navigate to the home page. So we add an effect for navigating away from the login page to the home page. And then we go back to the update function and add some more handling. So on login effects, on login successful, we just dispatch a navigate to home effect. And if it fails, we say, OK, we're no longer logging in. So we update the model. And we send an effect saying, show an error message saying that there was an error message, there was a failure logging in. OK. All good so far? Can barely see you, but I'm hoping that you're following. So, yeah. So here's a little bit about how we can implement effect handlers as well. And I talked a bit before about separation of concerns. So, and in particular, we wanted to separate out the UI from the business logic, which is what we do through these events and the update function. And here's an example of how you can separate out different handling of different effects from each other in what I think is a nice way. So this is using an Rx-based framework for handling effects, since they are asynchronous and impure. And so we have this builder or tool subtype effect handler, which you say when an effect of this class happens, then do this thing. And this thing can be one of 4. There are 3 examples on the slide, but there's a 4th one. So 4 is an action, which is basically just run some code. And I don't care about the data in the effect, and I'm not going to generate any events. Just run this code, and I'm done. So the navigate to home effect is, it's the end of this loop. So it's just, show the page, show the home page. That's it. There's the consumer example, which is for the error message thing. It's not going to generate any more events, but we need data from the effect. So we use the consumer of the effect, and we extract out the error message and display that somewhere on the view. And then the final thing that's here is a transformer, which is like the most complicated thing, where you use an Rx transformer. So a transformer is a function from observable of one thing to observable of another thing. And for the login thing, where we actually will emit events, that's what we're using. And the 4th one, which isn't displayed, is when there is a synchronous one-to-one mapping from event to effect, then you can just add a function that does that mapping for you as well. And here's an implementation of a login handler. So I'm going to try to walk you through it. We have an observable of attempt login requests. So you see, it's already been split out. It's like it used to be effects, but now this tool has split it out, so you're only getting the attempt login ones. You don't need to do casting and stuff. It's a little bit nice. And then we do a switch map, which means that if we're currently processing a login request and another one arrives, we're going to discard the previous one. So that's why the switch map is there. And then we call some backend service, login service. We say login with the email and password from the effect. And then depending on the result, if it's success, then we send a login successful event. If it's a timeout, then we say we failed to log in, and we give an error message. And if it's another failure, then we say login failed with a message from inside the login service. Everybody good with that? Hope so. So we talked about 2 kinds of events. We have the UI interactions, which is when the user does something, and we have the effect feedback, which is when an effect handler has done something and needs to communicate that back. There's a 3rd kind of event that you can have, and we call them external events. So it's things that are, there's not an effect that triggers them. They just happen in the outside world. So if you're interested in, say, listening to the battery level or network changes or something like that, then you can do that. So adding that into the diagram, this is the full picture of what a Mobius loop looks like. There's a lot of loops, as you can see. Where we have the update function, which is the heart, and then they have the user interface, which observes the model and emits interaction events. There are effect handlers that handle effects and emit events, and then event sources that just push in events that happen. we have some, so I think the only thing you've seen so far that has had Rx in it was this effect handler thing, and that actually lives in an add-on module to Mobius, which is called Mobius RX, or RX2, depending on which flavor you want. So we have some utilities in there that make it easy to work with Rx, so you can do the effect handler. Or you can see the Mobius loop as an observable, you can create event sources and so on. A thing I really like myself is this test library that we have. So testing utilities for validating your business logic in Mobius. We have this thing called an update spec. And it makes it super easy to validate that the loop behaves in the way that you want it to. So if you have a model with an email and a password, the credentials have been validated, and you're not logging in. So given that model, when a login requested event happens, then the next state that comes out should have a model where the logging in has been set to true, and an effect to attempt to log in with the given username and password. So this is how you write tests for your update function. And the good thing is that there's also a method called when events, which allows you to pass in a sequence of events. So if, for instance, you have a situation where you know, there are races and you know, things can happen in weird order, you can just write a unit test for that, and it'll run in way less than a second, and you can get the right, you can validate that you get the right behavior in that case. Cool. So looking at the objectives we had for Mobius, we wanted to have a framework and not just a pattern. We have that. It's reactive. It's, everything is asynchronous. There is no ordering anywhere. Like you don't know. The only thing you know is that your events are going to be processed in sequence. You don't know in which order they're going to get passed in, and you don't know in which order effects are going to be handled, because that's actually what the world looks like. So it's good to just embrace it. We have separation of concerns. So you have the separation between the UI and the business logic. We have the separation of handling of different events from each other. We have an interesting separation, I would say, of like the description of what should happen. That's an effect. It's a description of something that should happen, and then the implementation of how it happens. This is a difference from Elm, for those of you who know about that, where the command is actually the implementation of how it happens as well. And we have a separation between different kinds of effects from each other. And the code that you write is synchronous, or looks synchronous, because much of the handling of like concurrency and stuff has been moved out into the framework, so you don't need to think about that. So I have a slide here as well to compare it a little bit with MVI. Clearly we knew about MVI when we created Mobius, so like why did we do that? And these are some of the reasons. I think that probably Mobius is like a subset of MVI or something like that, but I'm not completely sure. One thing that's slightly different is a naming thing. Like MVI talks about intent, we talk about events. And one reason for that is that not all events are actually intentional. So like nobody intended to drop the battery level below a certain point, it just happened. So event is a slightly better name, but it's not really significant. We wanted it to be less RX intense. Not everyone, but I think RX is hard. So it's great for simpler things, but when you have to combine different chains and so on, and handle state in it, then it gets hard. Probably the most important distinction is that in MVI, you have an intent, and then you have an action and a state change. And as far as I can understand, there's no like real prescription of which order the action and the state change should happen in. Like there can be races there. In many of the examples that you see here on out in the wild, it's like the action happens before the state change. So when some intent happens, then you do something, you call a backend service, something like that, and then you reduce that state change in the reducer. Whereas Mobius says that an event happens, we update the state, and then sometime later the action gets executed. And this is probably, this is probably good primarily because it helps make it easier to deal with races. So if you have two actions, say, one example I keep using is our search feature at Spotify, where as the user changes the query, we send more search requests. But whenever you send a request to a backend service, you have no idea when the response is going to come back or if it's going to come back at all. So responses may come back out of order. And if you search for foo, and then you type in fight, and you want to have Foo Fighters, then the search request for foo is going to go away, then the search request for Foo Fight, and then the search response for Foo Fight might come back, and then the search response for foo, in that order. And then you don't want foo to overwrite Foo Fight. If you have, and with Mobius it's really easy to handle that kind of thing, because you have access to the state. You know when you're sending the second request that you sent the previous one. Whereas if you have two actions executing in parallel, you may not necessarily know that you sent the previous one. That's actually the reason why we made this explicit decision. But I think that MBI is great, and I think if you haven't tried it, then you should. Or you can try Mobius. I think Mobius, as I said, is probably a subset of MBI, but I'm not completely sure. Cool. OK. So we have been using Mobius for about a year now. And, or we've been working on it for about a year. We've been using it in production for maybe 6 months. And some of the side effects that came out of this, better debuggability. We sort of knew about that one. And the thing that happens is you have, when you have immutable models, you have immutable events and immutable effects that are all simple value objects. If you want to understand what happened in your feature, you can just log them. And Mobius comes with pre-built hooks for logging everything that happens. So you do something, and then something weird happens, and you just look at the log and filter it by Mobius, and you see, OK, these events happen. Oh, OK, that field there is wrong in the state. OK, there's a bug, I'll fix it. Super easy. Almost no need to use a debugger, because you get the information you want anyway. A completely unexpected thing was this unified modeling approach. So what that means is when we started building features with Mobius, what you have to do is you have to figure out what are the events that can happen. What do I need in my model to be able to make decisions based on those events and to render the UI that I want, that the designer has decided that this is the UI that we want. And to get things to happen in the back end or other things, what are the effects I want? And it turns out that this model of thinking with events and a model and effects is actually really easy for people who are not very technical to understand. So it improved our communication between product owners, developers, and designers a lot, and led to this thing that we call the Mobius modeling flow, or MoFlow. So there are MoFlow sessions at Spotify every now and then. And what happens is, if you do a MoFlow session for a feature, the designer has made some sketches, this is what it should look like. And then you do a MoFlow session, and you get into the details. OK, so this event and that event, and then this effect, and so on and so on. And you can even start writing the unit tests for the update function. When you do that, you discover pretty much all of the corner cases that the designer didn't think of. And you do that before you've written anything that's difficult to write. This is usually they might do a MoFlow session in the morning, write the unit test in the afternoon, and then you know exactly what your feature is going to be. You don't have the UI, you haven't got maybe the effect handlers and the backend things, but you know that you can validate that the UI is implementable as designed, and the designer can go back and fix issues and answer questions and so on. So it leads to better planning in that session as well, because once you have that, then you have a to-do list. OK, I need to build this effect handler, that effect handler, this effect handler, and the UI. And complete surprise to us, but it actually worked really nicely. And it turns out that there's some prior art for that as well. There's something called event storming, which was a process from 6-7 years ago that people were recommending. OK, so coming up, maybe. We have an Android Studio plugin that helps you generate. We wanted to have a very standardized way of building Mobius features. So we have an internal IntelliJ plugin that allows us to generate code. So you get a scaffolding for, like, this is where you put your effect handlers, this is where your update function goes, here are your model and event effect classes and so on. So that the idea is that all of the features that are built with Mobius should be familiar to someone who's built another feature with Mobius. Maybe, hopefully, we'll get to the point where we can open source that, make it available. We have a Swift version of Mobius in the making, which would be great for us, because that way we could share more of the business logic more easily between iOS and Android. And hopefully more than that. So we actually had a thesis worker who did his master's thesis based on Mobius, and he implemented Mobius in Objective-C, in Haskell, in Java, in Kotlin, and in Dart, I think. So maybe some of those will make it out one day. That's all I had. So any questions? There are questions?
Do I need to use the mic? Hey, thanks for a great presentation. As far as I can understand, basically the state is the model and the effects. At any given instance, the state of the application is defined by the model and by the effects.
Yes.
Model alone is not enough, because the effects are generated from the input function, right?
Right. Yeah.
That's not the question.
Okay.
Okay. So I will ask the question, and then you can correct me. The question is, how do you handle process death with all this framework? So save and restore.
Right. So the first one, I would say, like, effect handlers typically are stateful, and effect handlers might have a Mobius loop inside them as well. So you're right. I mean, if you want to look at the whole application state, then the model for a single feature is obviously not enough. It's just the thing, like it's really state for the UI, I would say, in this case. But we also use, it's interesting because we also use Mobius in quite a number of places where there is no UI involved at all, because it's an easy way to deal with concurrent events happening and where you want to be very sure that the state transitions are done correctly. That's an aside. So process death, you mean like configuration changes and so on, and persisting state?
Not configuration changes, process death.
Okay.
Because it's like a little bit different. Configuration changes, you keep your application, but when the process is dead, like everything, including your state, which is outside of activities and fragments, will be destroyed.
Yeah. So Mobius doesn't have any opinions on how you deal with that. It's like external to you. So probably you would need to somehow make sure that the state in your effect handler survives that, and you would also want to persist your model for the feature somewhere if you want to get back to the exact same thing. Yeah. There is one thing I didn't mention which helps you get going from something like that, and it's I talked about the update function, which determines when an event happened, what should happen next. There's also the init function, which determines when you start up a Mobius loop, what should happen then. And that takes a state, which is probably a persisted one from somewhere, and then it returns a first, which is kind of like a next, but it's a first. And the first has a model and some effects. So if you have some sort of loop that needs to kick off something when it starts up, you would use the init for that.
Yeah, that might solve this problem.
Okay.
Thanks.
Cool.
Hi, I got a question about how do you track the progress of when event starts, when it's emitted, and when effect goes and the state, the model changes. Do you have it inside the model, or there is some kind of hook to connect with the effect progress?
I don't think I understand the question.
User clicks the button, we must show the progress.
Yeah.
Who knows about the progress?
Right, so the model will say something like, if you remember the fields for the logging in, for instance. So the model knows about the state from a business logic perspective. So we're right now logging in. And then the UI will interpret that as, okay, I should show a spinner.
Okay, so you're doing it like in Redux way. So if you have a couple of operations on one screen, so you have like a you have to merge the progress state, right?
Not
You
sure
have
which-
two concurrent operations, and
Yep.
you have only one model for them on one screen, right? How do you merge the state for the progress?
Well, you can do that in many ways, I think. Like you can either have two different loops, you can have two different booleans in your model, or you can have one that's combined and managed by the update function.
Okay, so it's up to model. Okay,
Sorry?
it's up to model to have the progress state, etc.
Yeah. It depends on how. Yeah, you can do it in many ways. Yeah. Sorry for not being clearer.
Hi. First of all, thanks. I think we all can agree that a lot of people talk about MVI, but usually it's just a first slide, really with nice theory, and then pages of RX stuff is thrown at you, and you're like, nah, I will skip, maybe I will wait a bit more. And Mobius, I think it's, as far as I know, it's the first thing that actually is simple and is production ready. So I just gave it a try, and I feel that it's awesome. It's actually something feasible. You can just, it does the job.
Thank you.
Thanks. And the question is, how do you feed it into your architecture? On which level do you see Mobius? Because some people they are more reluctant. They keep it on presenter layer in terms of clean architecture. There are people that want to go more radical and to shape the whole app in Redux style in MVI. What's your take on this?
I think we have this app called Stations, which is experimental, but it's built entirely as Mobius loops. So you have one Mobius loop that manages the state of the application from it's now starting, the user is logging in, it's login, and all these things. And there's a backend service, or not a backend service, a service, an Android service, with another Mobius loop in it, and then there are Mobius loops for each of the features. So I think maybe that's not quite the question.
Yeah. So would you describe your app as Redux architecture, the whole app, or it's still clean architecture with presentation layer built by Mobius?
No, there's still a clear separation between the presentation and the business logic. Mobius only, if you look at the MV star paradigms, I would say Mobius belongs in the M. It doesn't care about whether you use a view model or a presenter. You can use both. You don't need them because the interface is quite simple anyway. So we have written Mobius things with MVP, MVVM, and with just Mobius and view. So.
Thanks.
Thank you.